Okay, good morning, good afternoon, and good evening, depending on when you listen to this slide presentation. My name is Victor, and I'm going to be your anchor for today's training. So this is the Module 9 in the Introduction to Networking CCNA curriculum. Today, we're going to be looking at address resolution. So at times we call it the ARP protocol, address resolution protocol. So the question is, if we have our router assign IP addresses for us or to us, now there might be some issues, right? So how do we resolve that? How do we ensure that there is no issues as a result of people having IP conflict, people having two persons having one IP address, or people not being able to have IP addresses when they ought to, all of those kind of issues. So the ARP tries to resolve that. Now, in this module, the objective is that we want to explain how the ARP and ND enables communications on the network. We look at the MAC and the IP. We look at the ARP. We look at the neighbor discovery. When we say neighbor discovery, we're trying to discover the routers and switches and the PCs and whatever around us. So that's sort of our neighbors. So we have to discover them. We have to understand what their IP addresses are. MAC and IP address, yes. So we call MAC physical address, we call IP logical address. So the MAC address is used for NIC to NIC communication on the same Ethernet network, the network interface card. So that's that hardware. We need the IP address. Then for IP address, we need to send packet from source to destination, right? We need to understand that. So those are the two primary addressing systems that we have. So when the destination IP address is on a remote network, then the destination MAC address is that of the default gateway. Because if this guy is the guy that is taking us away from this network, so this is not going to be the guy that we're going to need, and the IP address to send stuff away, no longer the IP address of this guy. So we have stuff like destination MAC, destination IP4 address, source MAC, source IP address, right? So you see, ICMP version 6 is used by IP version 6 to associate the IP version 6 address of a device with the MAC address of the device. So if we are operating on IP version 6, so the Internet Control Messaging Protocol is going to use the IP version 6 to do that mapping. If we're on IP version 4, it's going to use the IP version 4 address to do the mapping. So there's a packet tracer lab here that talks about identifying MAC address and IP addresses. I think I've done that time and time again in doing this program. Just run ipconfig and going to have that. ARP. So a device uses ARP to determine the destination MAC address of a local device when it knows its IP4 version 4 address. ARP provides two basic functions: resolving IP version 4 addresses to the MAC address. Yes, each system is going to have its own IP address, and each system is going to have a MAC address. So, but we need to match these two guys. Then, of course, ARP does another thing by maintaining an ARP table, right, of IP version 4 to to MAC address mappings, right? If I do something like this, let me clear my screen. ARP, sorry, ARP-A. So I'm going to have something like this. I'm going to have, so the command I typed was, sorry. The command I typed was ARP-A. So I'm going to have the IP address, the MAC address, the IP address and the MAC address. And it's going to tell me if that is a dynamic DHCP server that is working, or whether it's just an assigned static IP address, right? So this is what you call your ARP table. Very, very important. So the guy keeps track of that, maintains that table that maps the IP address to the MAC address. Functions: to send frame, a device will have to search the ARP table for a destination IP4 address and the corresponding MAC address. So typically what happens is that I'll need to know who have, if I get something from this guy, I need to know, please, what's the MAC address, what's the physical address? Once I get that, I'll be able to identify which system needs that particular information. So if there is no ARP table found, then the device sends an ARP request. So the ARP request will have to say, please, I need an ARP, I need the protocol, or rather I need an IP address for that particular system. So it gets that information, then it's able to communicate. Don't forget, we're talking about communication. Without these addresses, there wouldn't be communications. So there's a video that covers, that explains ARP request for a MAC address. It's on the Cisco LMS. Quite some videos there. Okay, so entries in the ARP table are not permanent. They are removed when the ARP cache timer expires after a specific period of time, or when you restart your system, or when you restart your router, or when you restart any of those switches. So because it's just temporary, just a table that helps to identify the different MAC address and their the IP address of those pieces that have the MAC address, basically for communication purposes. You see it? IP address, MAC address. So if on a Cisco router, right, you say show IP ARP, so you have that. You see, you have the IP address, you have the MAC address. Then you have the interface, whether it's a gigabit or gigabit, or whether it's a fast internet. If you're on Windows, this is Cisco. If you're on Windows, you just say ARP-A like I did, and you go to get the IP address and the corresponding MAC address, and if it's static or dynamic. Okay, these are security issues. We'll talk about it more later on. Packet tracer, examine ARP tables. So there's a lab there that has to do with packet tracer. So we'll do a separate video for this. This should be module 9. So if we go by the labs, module 9. It seems there's no lab in module 9. Is this module 9? Yes, this is module 9. Seems there's no lab in module 9, but I'm seeing, so there might be some issues with this. Let me see. Module 9, there's none. Let me see the packet tracer source files. Module 9. Okay, there is packet tracer. So we're supposed to have the document. So we should have to resolve that for our remote students. So the module 9 packet tracer labs identify MAC and IP addresses, examine the IP ARP table, then do IP version 6 neighbor discovery. So these are some of the labs that are 33 in number for the entire CCNA 1 course. Okay. So copper cabling. So there's a video in your Cisco LMS that explains the process of how IP version 6 performs address resolution using the ICMP, that is the Internet Control Messaging Protocol version 6, enable solicitation, enable advertisement message. So how it happens is simply, I come on the network and I need an IP address. So basically, I'll have to make a request. I'll have to solicit. Once I solicit, the router is going to do some advertisement. It's going to tell me, okay, this is what I have. So I'm now going to pick, or it's not going to assign from the available IP addresses, so that that is now assigned as my IP address. So that's what happens with respect to neighbor solicitation and neighbor advertisement. So this is it, solicitation message. Hey, whoever has this, send me your MAC address. So it now says, okay, hi, this, I am this, and my MAC address is this. So that back and forth communication between the sender and the receiver so that they can understand them. So that's why it's called neighbor discovery and address resolution. Okay, so now packet tracer there. I'll do that in a packet tracer lab. Okay, that's the end of the module. So what the module is about is us understanding IP version 6, or rather us understanding the ARP protocol and how it works. It's just for us to be able to resolve IP addresses, right? So we have two major types of addresses, the physical address, the MAC address, and the logical address, which is the IP address. But for whichever case, in MAC addresses, we'll talk about the CAM table, the content addressable memory. But in IP address, we talk about the ARP table. For the MAC address, we have that table that has for each of those systems their MAC address. For the ARP table, we go a step further in layer 3. We now have the IP addresses and the MAC addresses being mapped so that whenever somebody comes on the network, he has to solicit and ask for an IP address. Once it's given, he's able to now communicate with the neighbors, able to now communicate with others. Okay, thank you very much for going through this module. It's a very short, brief module. See you in module 10.